Alright, we're going to move into section 2.6, which is algebraic proofs. And I know this is a geometry class, and we're supposed to be working with shapes, and I promise at some point we eventually will, but for a while we're still going to be writing out sentences and statements and doing a little bit of algebra. So we're starting with algebraic proofs, honestly, because they're just easier, and you're very used to doing something similar to them. So we're going to start out by defining what a proof is. So a proof is an argument that uses logic. Definitions, properties, postulates, axioms, and theorems to show that a conclusion is true. To show that a conclusion is true. Okay, so that's the formal definition of a proof. Now, you don't have to recite that or be able to reproduce that. You just need to know that a proof shows that a conclusion is true. The way that a proof works is we're given some information and we're told to prove something based off of that information. But before we do that, especially before we do it algebraically, we need to write down some properties. So we're going to write down some basic properties of real numbers. And we're going to specify that in all these explanations and things I'm about to write, that A, B, and C are any real numbers. Okay, and I know that you don't know why we're writing what we're writing, but just write it, and we're going to make a table. And we're going to write down 1, 2, 3, 4, 5, 6, 7, 8, 9 properties. And so we're going to split our paper. You're only going to need 9 lines to fit all this in, I think. So we're going to start by writing the name of our property on this side. So this will be our property, and this will be our statement that goes with it. So we're going to start with something called the addition property of equality. Okay, and this may not make a lot of sense at first, but I promise it will when we're done. The addition property of equality says that if A equals B, then A plus C equals B plus C. All this is saying is that if you have an equation, as long as you add the same thing to both sides, your equation is still balanced. That's the addition property of equality. You already know it. You've just never written it down. Right? We're going to have the subtraction property of equality. It says if A equals B, then A minus C equals B minus C. So again, same thing. If you have an equation and you subtract something from the left side, you have to subtract it from the right side. Then we're going to have the multiplication property of equality. And again, it's going to say if A equals B, then A times C equals B times C. And I bet you can guess what the next one's going to be. It's going to be the division property of equality. This one's going to be a little unique. It's going to say if A equals B and C is not equal to 0, then A over C equals B over C. And so the reason the C not equal to 0 is in there is because up here we said C is any real number. Well, 0 is a real number, and we can't divide by 0. So this is part of learning about proofs and logic, is we're accounting for everything here. So when we said A divided by C equals B divided by C, well, we put a 0 on the bottom there. Those aren't true statements because you can't divide by 0. And so you'll see as we go, we'll start to have little things like this thrown into our problems and into our statements. They typically don't mean anything that you need to worry about right now. Just be aware that they're there, and when you get a little higher up in math, you'll start to pay more attention to them. Our next one is going to be called the reflexive property of equality. And it's really easy. It says that A is equal to A. So if it helps you to remember, reflexive is like a reflection. You get the same thing on both sides. It looks exactly the same. It's not flipped, it's identical. All right, our next one is called the symmetric property of equality. And the symmetric property of equality says if A equals B, then B equals A. Okay, notice this one has your equation flipped, right? A equals B and then B equals A. A lot of people want to call this one reflexive because it looks like a reflection, a mirror image. But this is not reflexive. So make a special note of that so you don't make that mistake. Reflexive is when it looks exactly the same. It'll be like 2 equals 2 or 5 equals 5. That's the reflexive property. All right, our next one is called the transitive property of equality. And it says if A equals B and B equals C, then A equals C. And now we've seen something very similar to this before with our law of syllogism that said that if A equals B and B equals C, then A equals C. And so we've seen this pattern before. Transitive property and the law of syllogism are basically the same thing. So we just got 2 more. We've got the substitution property of equality. And it says that if A equals B, then A can be replaced by B. Okay, our last line, is one that you know well. It's the distributive property of equality. And it says that A times B plus C is equal to AB plus AC. And you know that one. You just have to be able to recognize it now and write down when you see the distributive property of equality. So there's all of them. Pause it if you don't have them. Finish it all out. And then move down here. We're going to do a quick example. Only one. All right, here's our example. It says prove that if 4m minus 8 equals negative 12, then m equals negative 1. And so what we want to get used to seeing and doing is writing down what our given information is and writing down what we're being asked to prove. So we're given the fact that 4m minus 8 equals negative 12. We're being asked to prove the conjecture that m equals negative 1. Now, I know you can all do that. And so the way you would do it is you would write 4m minus 8 equals negative 12. And you would go algebra crazy. But we're going to do this a little bit differently. We're going to make what's called a two-column proof. And the left column is going to be our algebra. And that column is going to be our statements column. These are statements that we believe are to be true based on facts, logic, definitions, theorems, postulates, things that we can prove. And over here is going to be the reason, or the name of the thing that lets us do that. And you'll see what I mean in just a second. So 4m minus 8 equals negative 12. Well, the reason I know that that's true, the reason that I can say that confidently, is because it was given to me. Right? I didn't do anything to find that. Somebody gave that to me. And so that's given. Your first step in any proof is always the given information. And then you know that you would do this, plus 8 plus 8. Now if you notice, I'm going to write it kind of small there, and we want to kind of think of that as all on one line. So we added 8 to both sides, and now we're left with 4m equals negative 4. And the question is, how did we come up with this next statement? It's because we added 8 to both sides. So if we go back up and look at our properties, we saw that the addition property of equality says that we can add the same thing to both sides of an equation. So we come back down here. The reason that 4m is equal to negative 4 is because of the addition property of equality. And notice how I abbreviate that. I don't expect you to write all these things out word for word, sentence for sentence. We want to get efficient, and the way to get efficient is to abbreviate and use shorthand. But your abbreviations have to be clear. So I need to know that it says addition property of equality. You can't just put APE, right? I need a little bit. So give me a little bit, and I'll be able to figure it out. So our next step would be to divide both sides by 4. And so our new line will say m equals negative 1. Well, hey, that's what we wanted to prove, right? So we're basically done. We just need to state why we can say from this line is true. And that's because we divided both sides by 4, so that's the division property of equality. And so whether you know it or not, that was your very first proof, and should feel good if it made sense. And if it doesn't make sense, don't worry. We're going to do so many of them that it's not going to matter in the end. Have a great day.